Hello, good morning, students. Hello. Hi, good morning, good morning. Okay, today we are going to see a few more sums on first chapter, rational numbers from Adi Sharma. Okay, so these are the most common expected questions. So you can just call it as a half marathon where I'm going to cover for half the syllabus. So let's see one by one. Now, for today, let's go for the okay, and let's start. Find the HCF and LCM of 90 and 144 by prime factorization method. A very basic question. So prime factorization for 90. So 2 table, 2s are 45. From 5 table, 5 nines are 3, 3s are 3, 1s are. Therefore, the factors of 90 is 2 into 3 square into 5. The next 144, again start from 2, 2 sevens are, 2s are, 2 3s are 6, 6 are 12, 2 1s are, 2 8s are, 2 9s are, 3 3s are, and 3 1s are. Therefore, the factors of 144 is equal to 2 to the power of 1, 2, 3, 4. 2 power 4 into 3 power 1, 2, 3 square. So these are the factors of 90 and 144. Okay. So to find the LCM of these two numbers, 90 and 144, what we have to do is write all the numbers 2 into 3 into 5 and write the maximum power. So you have 2 here and here 2. The maximum power is 2 power 4, 3 square and 5 power. Now to find HCF of these two numbers is equal to write the numbers which are common, or I can write all the numbers and write the minimum power. 2 power 4. So minimum power is 1, 3 square is common. Here I can write it as 5 power 0, which gives me 1. If I have to write it as 0. Instead, leave this if you are getting confused. Then just take the common factors. 2 is common and 3 square is common. Therefore, this is the HCF of these two numbers. Okay. Yes, if you want, you can take down those who are following. Now, moving to the second question. Second question. The HCF of two numbers is 16 and their product is multiplication is 3072. Now find their LCM. So before getting into this some solution, let us take the important formula is let the two numbers be x and y, for example. Therefore, the formula is multiplication of their LCM and HCF is equal to product of the number. Is equal to product of the number. Okay. The LCM into HCF is equal to x into y. Okay. This is the important formula which we use in the first chapter. Okay. X and y or A into B, anything, whatever they have been taught in the school. So now they have given HCF as 2 and you have to find the LCM. So LCM which we have to find, instead of HCF I can substitute it as 2 into product. What is the product? X into Y. It is given as 3072. Is it so? HCF of two numbers, you should not write 2, it is 16. Okay? So this is where they do the mistakes. In question, they would have given you 2 like this or TWO 2. So whatever it is, HCF of the two numbers is 16. So you should substitute 16. Now, LCM is equal to 3072. On transposing, it becomes divided by 16. That is equal to 2 tables, 8s are 1, 5, 3, 6. 36 is divisible by 8, therefore this number is divisible by 8. 8 ones are 8. Remainder is 7. 9s are 72. Remainder is 1. It is 2. Therefore, the LCM of these two numbers is, that is any two number is 192. So this formula is very important. Okay. Now, the most important question, third question. Third question is, prove that root 3 is an irrational number. Okay. Root 3, root 2, root 5, root 7. Anything can be given. Very important question in your first chapter. So root 3, what is the method we are going to follow? Is the same for root 2, root 5, root 7. So any number can be given for you to prove it as an irrational number. So now let us start to prove the root 3 as irrational number. So we are going to use the contradiction method. So in contradiction method, let us assume root 3 is an rational number. Root 3 is an rational number. That is, root 3 is equal to a by b. The rational number in the form of a by b, where b is not equal to 0 and a and b does not have any common factor. That is, the HCF of a comma b for these two numbers is equal to 1. This is what we have assumed. Okay. Now, square on both the sides. 3 is equal to a square by b square. 3b square is equal to a square. B square is equal to a square divided by 3. Mark this as equation 1. I have just transposed. Okay. Now, 3 divides a square. Then 3 will also divide a. Okay. This is according to the theorem. This is according to your theorem. Okay. Now, 3 divides a. 3 divides a. In the sense, 3 divides a will give me some number n. Let us assume this. So a divided by 3 is equal to n. Now, a is equal to 3n. Transposing, I will get a is equal to 3n. Now again, square on both sides. A square is equal to 3 square is 9, n square is n. Substitute this equation. Substitute in equation 1. B square is equal to, instead of a square, I can write it as 9n square divided by 3. 3 ones are 3 threes are. Therefore, b square is equal to 3n square. Okay. B square is equal to 3n square. N square is equal to b square divided by 3. B square divided by 3. Now, 3 divides b square, then 3 divides b also. So this is according to the theorem. Okay. Now, b square is being divided by 3, or I can say 3 divides b square and 3 divides b. 3 divides b and I get a number m. Let. Okay. Now the number what we have assumed is a by b. A is equal to 3n and b is equal to, when I transpose, I'll get b is equal to 3m. You know that we have assumed that there is no common factor other than 1. That is, the HCF of these two numbers is 1. But I have found a number 3 as common for both the numbers. Okay. So HCF is not 1 here. I have found 3 to be the HCF. Right. Therefore, why this contradiction is assumed? This contradiction is due to a wrong assumption. So what we have assumed? We have assumed root 3 is a rational number a by b. So this assumption is wrong. Therefore, root 3 is irrational number. So we have proved that root 3 is an irrational number. Okay, the very important prove that root 3 is an irrational number. Very important question for your board exams. Okay. Okay. Thank you. Thank you. Thank you.